Google wants to put AI data centers in orbit, and SpaceX is building the rockets to get them there. It's called Project Suncatcher. Solar-powered TPUs floating above the atmosphere, running AI workloads where electricity is free and cooling costs are literally zero. Here's the problem they're trying to solve. AI data centers now consume 4.5% of the entire US power grid. By 2028, that number doubles. We're running out of places to put them. Virginia just put a moratorium on new data centers. Ireland warned they'll crash the national grid. Singapore banned them for 3 years. AI companies are literally running out of planet. So Google's engineers asked a wild question. What if we just left? In orbit, you get unlimited solar power, 24/7. No clouds, no nighttime, no angry neighbors filing zoning complaints. The architecture is wild. Google's TPU chips mounted inside radiation-hardened satellite housings, linked together by optical laser communications. Basically a mesh network of AI processors floating in low Earth orbit. SpaceX isn't just providing rockets. They're pitching their entire orbital infrastructure, Starlink's communication backbone, Starship's cargo capacity, and their ground station network. It's a full-stack space computing platform. And here's why SpaceX is so eager. They're prepping for what could be the largest IPO in human history, $1.75 trillion. Landing Google as an orbital computing customer, that's the kind of contract that makes Wall Street drool. Remember, SpaceX merged with Elon's xAI back in February. They already run Colossus, one of the largest AI data centers on Earth, with over 220,000 NVIDIA GPUs. They know the compute game. Google's internal projections, and these leaked, suggest that within a decade, orbital compute could actually be cheaper than ground-based data centers. No land costs, no utility bills, no water for cooling, just sun. Google is targeting 2027 for prototype satellites, a pilot constellation by 2029, and if everything works, commercial AI operations in orbit by 2030. That's 4 years from now. Now the obvious question: latency. Sending data to space and back takes time. In low Earth orbit, you're looking at 20 to 40 milliseconds round trip. That's fine for training AI models. It's not fine for real-time inference. Google's solution? Use orbital data centers exclusively for training, the massive, batch-processed workloads where latency doesn't matter. Then beam the trained models back down to Earth for real-time inference. Train in space. Deploy on ground. But there's a problem nobody wants to talk about. Space radiation. Cosmic rays cause bit flips in silicon, random errors that corrupt calculations. On Earth, this barely matters. In orbit, running trillion parameter models, a single flipped bit could poison an entire training run. Radiation-hardened chips exist. NASA and the military have used them for decades, but they're 8 to 12 times more expensive than standard silicon, and slower. Google would need to build custom rad-hard TPUs that don't exist yet, and when something breaks, you can't send an SRE to space to restart a server. On Earth, you swap a failed drive in minutes. In orbit, a dead satellite is a $200 million piece of space junk. Skeptics are calling this a vanity project. Multiple aerospace engineers have pointed out that launch costs alone would eat the power savings for at least 15 years. And that's assuming 0 satellite failures, which, historically, is not how space works. But the believers have numbers too. SpaceX has reduced launch costs by 97% in 15 years. If Starship delivers on its promises, putting a kilogram in orbit could cost $200 by 2030. That changes every calculation. And Google isn't the only one thinking about this. Amazon has Project Kuiper. Microsoft has Azure Space Partnerships. SpaceX's own xAI division could run competing workloads on the same orbital infrastructure. This is about to become a space race, but for GPUs instead of flags. Here's the part nobody's figured out yet: data sovereignty. If your AI model trains in orbit, which country's laws apply? The Outer Space Treaty says no nation can claim sovereignty over space. Your data could literally be above the law. The environmental argument is actually compelling. Ground-based data centers burn fossil fuels for power and millions of gallons of water for cooling. Orbital data centers use neither. If this works, it might be the greenest compute option ever built. Step back and think about what this actually means.